Great. And then I'm going to share my screen and go through my whole spiel. Are folks seeing the full screen version? Callie, if you can give me a thumbs up, I see you on screen. Perfect, thank you. All right. Thanks, everybody. My name is Kyle Bocinsky. I'm the Director of Climate Extension for the Montana Climate Office. And this is a recording of the Native Resilience Working Group meeting on June 17th, 2025. Today, I'll be leading a little bit of a discussion of current drought status and drought outlooks for the United States, focusing on the Western US and on tribal lands, just as a way to brief everybody with an update. This is the current status of the U.S. Drought Monitor for the United States. What we see is exceptional drought and extreme drought conditions persisting across the southwestern United States, especially down along the U.S.-Mexico border. We see the reemergence of extreme drought, D3 drought, in the northern Rockies, and we see severe drought persisting across many portions of the high plains, of the central plains, and of the southwestern United States. I'll get a little bit more into detail on that as the presentation goes on. Just as a reminder to everybody, the U.S. Drought Monitor is a weekly product that has been produced by the National Drought Mitigation Center since January 4th of 2000, so over 25 years of consistent weekly drought assessment across the United States. In recent years, since 2008, this product has been used in order to trigger drought disaster designations and disaster relief by the USDA, Farm Service Agency, and many other entities across the country. This is just an illustration right here of how those maps have changed over the last 26 years. And I don't want you to take anything from this, except for that drought has been a consistent feature of the Western United States and our country since the inception of the U.S. Drought Monitor. And it comes as no surprise to any farmers or ranchers, any producers listening to this, that that drought is a consistent feature of our Western landscape. One thing that I do want you to take from this, though, is that in recent years we've seen some fairly exceptional drought conditions emerge across the contiguous United States, especially here getting to today, where we have those exceptional drought conditions across the southwestern United States and extreme drought conditions in spots across the Southwest and in the northern Rockies. So we can look at that full history as changing maps, which is pretty useful, or we can look at it through time. And when I look at these data through time, I prefer to look at them along hydrologic basins. Why? Because water runs downhill. And if we're talking about drought, we're really talking about a moisture deficit across regions. So I'm about to show you some graphs that are going to be a little overwhelming, so I want to just prep it. These are graphs that aggregate all of those blobs that we saw moving a minute ago across these major hydrologic basins in the United States. You're going to see graphs that go from the Pacific Northwest at the very top through the Missouri, California Great Basin, Colorado, and Southern Plains. So we'll get the western tier in the first 5 graphs, and then we'll get the eastern tier and some of the outlying regions. And here those are from January of 2020 through today. So this is over the last 5 years of drought across the contiguous US, again, starting from the Pacific Northwest, Missouri River Basin, California, Colorado, and Southern Plains, sort of our western states, are captured in these top 5 graphs. And what we can see is that we've had two major pulses of droughty conditions across these 5 regions over the last 5 years. One from 2020 through 2023, where we saw the emergence of exceptional and extreme drought across all 5 of these regions, and a general south to north and southeast to northwest flow of those drought conditions as certain regions saw drought conditions somewhat ameliorate, they started peaking in these other regions. What I want you to notice is that over the last year, we've seen a reemergence of these drought conditions in the Southern Plains, in the Colorado River Basin, and in our other basins. And what I anticipate is that this pattern will actually replicate itself over the coming months and years. We see it through time, and I want you to again focus on just these 5 graphs on the top, which are capturing the Western US. You can look at the other regions if that's your region, but in the Western US, what we see is often the emergence of droughty conditions in the Southern Plains, of extreme and exceptional drought conditions in the Southern Plains, moving into the Colorado River Basin, and then moving in a generally north and northwestern western direction, and then in a sense exiting out of the country through our northern border in the Pacific Northwest. We've seen that in 3 major drought episodes over the last 25 years, one in the early 2000s, one in the the 2012 drought that really triggered a lot of federal relief programs, and then more recently at the beginning of the 2020 through 2023 drought. What we notice is that other smaller droughts can be intense and do emerge in this region. We'll get into some of the reason why this is happening in a minute, but this is a fairly consistent pattern when it comes to how drought emerges and then moves across the contiguous US and especially across the Western US. So what does this mean for the Missouri River Basin and the Pacific Northwest? To me, it means that we should be expecting an increase in our droughty conditions just based on this pattern on how drought has tended to emerge and grow across our country. It's connected to a lot of climate patterns. How has drought grown and changed just this year? This map shows the US Drought Monitor number of class changes. So we've got, D0, which is just dry conditions, abnormally dry, D1, which is moderate drought, D2, severe drought, D3, extreme drought, D4, exceptional drought. If we're moving in the more droughty condition, this will look redder. If we're moving in the less droughty condition, this will look bluer. And this is what we see over since the start of the calendar year, since January 1st, across the US. We see across the northern Rockies and central plains and the northern high plains, the emergence of drought. It's getting droughier across this region. We see the same pattern across the southwestern US, especially Nevada and down at the outflow of the Colorado River, where we see major degradations, and across the Texas border with Mexico as well, where we've seen more degradations, droughier conditions emerging. Where has it gotten better since the beginning of the year? Well, anybody living out east, and my family is all down in the southeast, it's been very wet. So we've seen an improvement in drought conditions across the American bottom, across the southeastern United States, and up into the some portions of the Midwestern states, with some degradation happening in Illinois, in southern Wisconsin. The Pacific Northwest has also seen dry conditions, and this is actually one of our primary problem areas where we're seeing the emergence of very dry conditions. More on that in a moment. So here we are at our current drought status. What has led to this? Well, I just want to bring you through a couple of maps looking into the past before we jump into the future. So this is the total precipitation anomaly over the last 90 days. These data are as of 2 days ago, which is our sort of, we're on a 2-day lag. And then this is just looking at the amount of precipitation relative to normal, so relative to a 1991 to 2020 average over the last 90 days. Areas that are brown were drier over the last 90 days than normal. Areas that are green, oops, sorry about that. Areas that are green are wetter over the last 90 days than normal. What do we see? We see very dry conditions across the high line here in Montana, across all of the Western US, effectively Idaho, the Pacific Northwest, California, and in the Valley, very dry, Nevada, very dry, and then again, dry here across southern Arizona, southern New Mexico, and portions of the border area with Mexico. Where do we see that it's been wet over the last 90 days? Other portions of the high plains, and of course, the whole, a lot of Texas, a lot of the American bottom in the southeast. Sorry for those of you in Alaska and Hawaii, this product is only available in the contiguous US that I'm sharing. At the same time, over the last 90 days, we can look at temperature. And what do we see across the board, except for in portions of the upper Midwest, in some portions around the Texas Panhandle and Oklahoma Panhandle, what have we seen is really warmer than normal temperatures over the last 90 days across much of the United States. And these anomalies that are cooler are actually pretty close to normal. It's the deeper red anomalies that are really catching my eye here. When you join both of those things together, what do we get? We get less snow being kept on the landscape. We get more evaporation and evapotranspiration, plants releasing water into the atmosphere through photosynthesis. And the standardized precipitation and evapotranspiration index, SPEI, captures just that pattern. So what we're doing with this is we're actually blending our precipitation anomaly, our temperature anomaly, to create a map of SPEI, which is an anomaly in evapotranspiration and precipitation. It's a water balance anomaly. And what this is showing us is that the Northern Rockies, the Pacific Northwest, this area here has been very anomalously dry, has had higher evaporation and lower precipitation over the last 90 days, in some cases to very extreme levels, as well as down along that Texas Panhandle and Texas-Mexico border in southern New Mexico. We can look at the same thing just over the last 30 days. The story remains pretty similar. Just over the last 30 days, really anomalous precipitation levels, much lower than normal across the Western US, especially the California and Great Basin states, the Pacific Northwest, and the Northern Rockies, some across the Northern Plains and Upper Midwest as well. And then in terms of our temperature, much warmer than normal across the entire Western US, across the far south, including that Texas border area that's been problematic, cooler than normal temperatures across the high plains and upper Midwest. Those things combined, again, lead to a 30-day standardized precipitation and evapotranspiration index. Again, this is just the water balance. It's combining that precipitation and temperature that is much drier than normal for this region. Again, very dry in the Northern Rockies. That's where we've seen some big impacts to our snowpack. Very dry and warm up in the upper Midwest. Very dry down along the Texas-Mexico border. So that leads, in many other information sources, leads to the current map of the U.S. Drought Monitor that we see today. This map is produced every single week, brings in data like that I've shown you, precipitation, temperature, indices like the Standardized Precipitation Index, the Standardized Precipitation and Evapotranspiration Index, and many more in order to create an up-to-date assessment on where drought is on a weekly basis. This in turn gets used by the USDA to declare secretarial disaster designations for drought. This is one of the triggering events that enables communities, counties, and tribal communities to access federal disaster aid when it comes to drought. Unfortunately, this product has not been updated since mid-April. And I actually sent out an email this morning inquiring as to why we don't have updated drought designation information on the USDA website. So more to come on that. We'll send out an alert to you all when that information comes. But as of April 22nd, this is what that primary. These are the counties that are hit by certain classes of drought in the U.S. Drought Monitor during this year. And then contiguous are adjacent counties because people understand that these blobs are getting drawn and the impacts of drier than normal conditions are often felt across county lines. So what are some of the things that can affect our drought conditions? Well, one of the things that we hear about a lot is El Nino and La Nina conditions. And so El Nino winters, this is mainly a winter phenomena in terms of our precipitation, temperature, and water balance across the United States. El Nino winters are warmer than normal in the Northern Rockies, wetter than normal in the southern, and tend to have drier conditions across portions of the Middle Great Lakes region. La Nina winters, like the one that we just experienced, tend to be colder and wetter in the Northern Rockies, drier and warmer across the South, and can be wetter in the Great Lakes regions. This is El Nino. This is the El Nino Southern Oscillation or the Oceanic Nino Index showing El Nino events in red and La Nina events in blue since 2000. And this is updated to the latest data. This is done at a monthly time step and actually accumulates data over 3 months in order to determine whether we're in El Nino conditions in red or La Nina conditions in blue. What we can see is that our La Nina this winter was a really weak La Nina. We were there for for a little while, but compared to historic La Nina events like the one that occurred from 2020 through 2023 or others, we were in a really weak La Nina event, and we were coming out of a pretty strong El Nino event that we had during 2023 into 2024. The Climate Prediction Center actually has models that run that predict what El Nino conditions and La Nina conditions may be like in the future. There's many of these. They create a whole spectrum of simulations that they run on a monthly time step. What I'm showing you here is all of those different simulations, so you can get a sense of how much spread there is. Notice that the spread gets wider as you go into the future because we're bad at predicting things 6 to 12 months out, but it's narrower as we come from the present because we know what conditions are right now, right? This dotted line is the average, though, of all of those different simulations of what the future might hold. And that average is suggesting that we may go into another La Nina winter this coming winter. That is the current state of El Nino. Looking at it another way, these are just the probabilities that are that were put out just last week, I believe, by the Climate Prediction Center for June 2025. The probability of being either in blue, a La Nina condition, in red, an El Nino condition, or in gray, the messy middle. In the messy middle, we don't have a lot, we're not having a lot of control over what El Nino, isn't having a lot of control over what our weather patterns are looking like. The most likely May, June, July scenario is that we are where we are right now. We're in that neutral zone, that messy middle, where we don't have, where the El Nino Southern Oscillation isn't having a strong influence one way or another on our current weather conditions. As we go through this, the summer and into the fall, this is August, September, October, November, and so on. What we see is an increase in the likelihood of La Nina conditions, what I just showed you, and a decrease in the likelihood of neutral conditions, to where once we hit the winter months, we're seeing about even odds of La Nina versus neutral conditions and low probability of going into El Nino conditions. We can also look at this in reference to this history of drought. Here I've just lined up that same Oceanic Nino Index and the same 25 plus years of the US Drought Monitor. And what we see is that La Nina conditions, especially persistent ones, tend to correlate with, especially across our Western US states, with these big outbursts of drought conditions, and this emergence along our southern states and in the Colorado River Basin, and then the progression of drought as we move out of La Nina conditions across northward and westward across the California Great Basin, Missouri, and Pacific Northwest states. So this persistent La Nina conditions that are being predicted for this coming winter by the Climate Prediction Center suggests that we will continue to have the emergence of droughty conditions across the Western US. But what does the nearer future hold? I'm going to run you through some more certain predictions for the next week to 2 weeks, and some less certain predictions going out 6 months, 3 and 6 months, so seasonal predictions. Over the next 6 to 10 days, we anticipate cooler than normal conditions across the Western US, especially across the Central and Northern Rockies into the Great Basin, and above normal temperatures across the Eastern US. Pretty strong gradient there. We expect above normal precipitation across the northern tier of the country and across this droughty area down here. This is good. This is good for our near-term drought conditions across both of these regions, where we have seen much drier than normal conditions and much warmer than normal conditions. We're getting some respite right now. We're all experiencing it. Our 2-day outlook starts to dry up a little bit and warm up. Near normal conditions is the expectation across the Pacific Northwest, and very close to near normal conditions across most of the West, with a little bit of below normal conditions down there in the Arizona, Nevada, and Southern California region. Our blob, our nice low pressure system, drifts east into the upper Midwest, and so near normal conditions in terms of precipitation across the Great Basin, wetter than normal or above normal precipitation conditions across the northern tier of the U.S. Our weeks 3 to 4, so this is going out through early July. You can consider this your Independence Day forecast. We're looking at a big shift back towards our high pressure systems dominating the Western US, where we see much above normal temperature conditions across the Western US, equal chances of above or below normal across the Southeastern US, so hotter than normal conditions and drier than normal conditions, especially up here in the Northern Rockies and the high plains, and then the messy middle, equal chances across much of the rest of the country. About the only places that are being predicted as having above normal precipitation might be that Arizona, New Mexico region. That would be nice. Some portions of Alaska, and then the southeastern US. Our seasonal outlook, this is covering June, July, and August. This was released about a month ago. They're actually about to release the next one. We just missed it by a day. So this is a month old, but the story is going to remain the same. The seasonal temperature outlook for this summer is just hot, 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 hot across the contiguous United States, hot above normal conditions as well in terms of temperature across Alaska. So it's just going to be a hot summer. And unfortunately for us in the Pacific Northwest, northern Rockies, and northern plains, we're seeing below normal seasonal precipitation outlook for summer of 2025. I anticipate that this is really going to aggravate our drought conditions across the Pacific Northwest and in northern plains regions. Perhaps above normal precipitation continuing across the southeast, that could be good. It'd be nice if we had a good strong monsoon coming into the southwest. And we all, if you're down in the southwest, you know how important that is. We'll really be looking at it around July 4th to see if that monsoon ramps up. Hopefully some wetter than normal conditions across Alaska. And then going into the fall, this gets pretty speculative. It's really difficult to do climate prediction going out 6 months, but I wanted to share it with you. This is the September, October, November 2025 Climate Prediction Center outlook, and the story is much the same. Above normal temperatures across the entire United States and Alaska, and below normal precipitation covering the high plains with equal chances. So half the models are saying it's going to be wetter, half the models are saying drier. That would be equal chances across much the rest of the country. About the only wet places on the map are the extreme southeast and the Atlantic and Gulf coasts, and the North Slope of Alaska. So when we take the CPC outlook and turn it into drought maps, this is a monthly product that gets released by the National Drought Mitigation Center and the Climate Prediction Center. These data were released on May 31st. We'll expect a new one at the end of June. And what this is showing us through all of June 25 where we expect drought to get better. Those are those green areas, and improve. These are these tan areas. And we see that down here in the Florida Panhandle, or sorry, the Florida Peninsula, and some here in the Central Plains, and where we see it to persist, the brown areas, or develop, so get worse. And that's what we see in yellow. So over June, which is almost over, believe it or not, we only have a week and a half left of June. We expect the expansion of drought in the Pacific Northwest, in the high plains, and creeping northward through California. And then if we look at a seasonal outlook, this is through August 31st, much the same trend, a continued expansion of droughty conditions. And this is just using that CPC outlook. So this is using those predictions of precipitation and temperature and what we expect the drought declarations to follow. We see an expansion of drought conditions across the northern plains. Something that we're really keeping an eye on right now is our fire season, and I know all of you are as well. This is an experimental product, but I think it's really useful. This is the burning index, which is just an index of, compared to normal, how we can expect fuels to react on our landscape. And this is using those same Climate Prediction Center forecast, except in a gridded way, and saying what is the likely fuel response across the contiguous U.S. Given those conditions over the next 4 weeks. Red areas here are areas that are a lot drier and a lot more prone to burning over the next 4 weeks. Blue areas are areas that are less prone to burning than normal over the next 4 weeks. And what we see is much of the West, and especially the central, northern, and southern Rockies, are we're seeing burning indices that are much higher than normal over the next 4 weeks, given those conditions on the ground, low relative humidity, high temperature, and in often cases moisture deficits from precipitation. That translates into the significant wildland fire potential outlook, which is put out by the National Interagency Fire Center on a monthly basis. This one was issued on June 1st. The next one will be issued July 1st. And they do a monthly outlook where, again, these are rough hydrologic basins. And what they're doing is trying to capture the likelihood of significant wildland fire across these regions. Red areas have an above normal wildland fire potential. Green areas, we don't see any of them on the map, would have a below normal wildland fire potential. And then the uncolored areas are just sort of normal. So if you're normally hitting a strong fire season, and I know some of my colleagues down in the Four Corners region, this is the driest month, right? We haven't hit the monsoons yet. This is when we see those fires. Normal can mean pretty high fire potential. So this is just relative to normal. And what we see is across the southern New Mexico, southern Arizona, and then the Four Corners up along on the northern edge of the San Juan River basin. That's where we're seeing in the Southwest above normal wildland fire potential right now. Also, the California coast up into the Sierra Nevadas, and then the eastern flanks of the Cascades over into the Idaho Panhandle and the sort of northern Minnesota and northern Wisconsin region of the upper Midwest are highlights of this map right here. As we move forward in our summer, that map's going to shift. It's going to shift not only because we do anticipate a monsoon, it's shifting because of our Climate Prediction Center outlooks for these regions. And what we see is an enhancement of above normal wildland fire potential across the Pacific Northwest, across the Northern Rockies, and portions of the High Plains. Also, the emergence of significant above normal wildland fire potential across the Southern Plains, Texas into Oklahoma, persistence of that same potential across northern Minnesota, as well as in Hawaii. And then that's much the same story as we move into August and September. So the outlook for our wildland fire is dry conditions down in the Southwest, but the emergence of an intense fire season, and we can all feel it, right? Our snowpack degraded much more quickly than normal this year. We've got a lot of fuels on the ground, and we're anticipating an active fire season across the Pacific Northwest and Northern Rockies into the High Plains. We also should be keeping an eye right now on our reservoir status. So I just want to hit three major basins across the western U.S. This is for the Missouri River Basin. These are each produced by different entities. Since the Army Corps runs many of the reservoirs across the Missouri River Basin, they produce this, which shows us that we're up towards normal in terms of pooling in three major reservoirs: Fort Peck, Garrison, and Oahe. The system as a whole is pretty close to normal. This is where we're at in terms of 2025. What we'll notice is that average is these dashed lines. That's where our sort of total system storage is usually. 2011, big flood year, where we had one of our maximum on record storage capacity and sort of peak amount of water coming downstream. 2024 is last year, which was much closer to average. This year, we're just below average, and our forecast is not to have this huge bump. We haven't seen it, and it's because our snowpack hasn't been there for us up here in the Missouri River Basin. We expect it to stay pretty flat. This is a combination of both the water that's coming downstream and control by the Army Corps of Engineers. They're going to try and keep this consistent as we move through our season. Down in the Colorado River Basin, what we're seeing is that our many of our reservoirs, especially in the lower basin, are pretty low. Lake Mead, our largest reservoir in the lower upper basins, is at 31% of capacity right now. Right below, directly in between tier 1 and tier 2 storage shortfalls, like Powell at 34%. This is as of last week, as of June 9th. Some of our upper reservoirs, Fontenelle's pretty low. Flaming Gorge, though, is nearing full pool at 87%, Morro Point at 95%. The Navajo and Blue Mesa reservoirs are sort of in between at 66 and 65%. A lot of our impacts that we're seeing in terms of our dry conditions are down here in the lower basin. Some of those are flowing into these reservoirs. Others are actually acting as a drain on those reservoirs, right? For both domestic and agricultural use. And then over in California, we see average or above average conditions across many of our reservoirs. This is good. It's looking dry in California, but we've got some good storage across our reservoirs, and you can see that here. So I'm going to end the formal part of my presentation there, and I'm happy to take any questions from anybody in the room, and I can go into more detail if necessary. Thank you. And I cannot see my. If you've got questions, you can drop them in the chat, or you can just raise your hand and ask them. And if not, that's okay too. Okay, well, hearing none, I'm going to stop sharing. Thank those of you who stuck around with me and who joined a little late. Again, we've got the recording of this. We'll get it up on nativeresilience.com, and we'll get the word out and try and get a larger contingent for next month's meeting. All right. Thank you so much. I'm going to stop recording, and if anybody has any final comments, we can. Maybe I'm going to stop recording. I'm going to try to stop recording. There we go.